Howdy. All right, thank you, Greg, for the perfect segue into static analysis. So Greg kind of talked about some of the software engineering practices that we want to start to embrace. And so specifically, I want to talk about static analysis and a tool we've created called JCrawler. So first of all, a little bit about myself. I'm Hunter Smith. I started my career at NI, like many of you did. I worked in applications engineering and K-12, working with LEGO Mindstorms and FIRST Robotics. Some of you may remember Waterloo Labs, the old YouTube experiment. That is me riding on the hood of an Oldsmobile Delta 88 that we kept in the NI parking lot for a few years before they told me I wasn't allowed to do that anymore. The door is still floating around the NI campus. Norm recently sent me a picture of it. After NI, I spent 7 years at SpaceX, working on a lot of the Falcon and Dragon test systems, as well as mission control and Starship mission control and stage 0. And then for the last 3 years, I've been working with JKI, and I've gotten to work on a lot of really cool projects. For Our Giants is Female, I wanted to highlight Carolyn Herschel. She has an amazing list of firsts there, but I thought this is particularly appropriate for static analysis because one of the ways that she discovered comets was by comparing starfield images. Of course, this is well before photography, so can anyone spot the comet? Anyone see the difference? Oh, it was right there. You missed it. There we go. But you know, it takes an amazing amount of skill and dedication to do that, and it's early static analysis, we'll call it. So when I first started at JKI, we had just started working on a project for NASA. And for the time that I've been working for JKI, this has been one of the biggest projects I've worked on. We are in the process of overhauling the data acquisition system for the ArcJet wind tunnel. It's a hot wind tunnel. It gets pretty hot in there, made for testing little pieces of heat shields, samples that may need to be exposed to that. One of my favorites is the 50 megawatt ArcJet basically shooting lightning doesn't quite get hot enough, so they have to add a laser on top of that just to get those temperatures up. But developing LabVIEW code for someone like NASA is a little different than if you're just developing it for a customer. You get a one-page memorandum of understanding, you have a statement of work, and you dive in. If you're working for one of these organizations, the paperwork requirements are a little different. Who here has written code for one of these or similar organizations? Yeah, so for NASA in particular, we were subject to a document called NASA 7150.2c. This is the Natural Procedural Requirements, and it goes through in details. It spells out SWE requirements, software engineering requirements, and lists specific codes. Those SWE requirements then reference other standards, which then reference other standards. And then depending on things like if it's safety critical or the software classification, you start to get in a dramatic web of requirements, and believe me, this diagram is simplified for readability. And so after pouring through all of those requirements, one of the first deliverables we had on this project was creating a software development plan. We wrote a 9,000-word document that goes through every detail of how we would develop the code, test the code, verify the code, document the code, track the code, and not just the code, but the defects, the project, the system updates. And it had to cover all 81 SWEs, as well as the 28 CWEs that we'll talk about later. And one of the specific line item requirements is to have static analysis. Now, in other languages, if you're in C++ and you say, hey, I need static analysis, you go to your IDE, you go to your repo, you check, I want static analysis, and then it gives you a giant full suite of tests already integrated with your CI worker, already built in. For LabVIEW, it's not quite that easy. So we ended up creating a tool to do some of the static analysis, but we found that once we made the tool, it didn't just help with static analysis, it helped with a huge variety of things on our SDP that helped us keep our code quality really high and helped us make really good tools. So could we make something that checks two boxes? One is satisfy the NASA requirements, and one is be an actually useful tool for developers, because those aren't always the same goal. A lot of times when you're working with these agencies, it's about telling a story. It's about creating prose, and then having the data to back that prose up and to be able to stand behind it. But it takes a lot to create the documentation you need for your deliverables, but we also want to try to create a useful tool. So what is static analysis? So static analysis, we're going to open up one file at a time, and we're going to run checks against it. In other languages, again, there's lots of different ways to do this. In LabVIEW, VI Analyzer is kind of the standard way to do this. How many of you use VI Analyzer regularly? Anyone have automated VI Analyzer stuff? All right. I think it will be. That's my goal, is to win you over. I have one nod specifically for you too. So when we created Crawler, we wanted to create something that had a few extra features that VI Analyzer didn't offer. We start from a path. That path can be a directory, a class, or a project. If it's a class or a project, it will expand the members of that class or project. And if it's a directory, it will just recursively navigate that entire directory. We almost exclusively use it in directory mode because we're trying to assess our repo as a whole, and so we want the entire repo. And that includes, setting up multiple repos. And for instance, ours are set up where one repo is a submodule of the other, and so we can have it set up where they can, when the super module runs, it runs everything, and when the submodule runs, it just runs that. Now, it's going to go through and discover all your files. Now, VI Analyzer supports VIs, VIMs, controls, but it kind of ends there. So we added support for LabVIEW classes, LabVIEW projects, and we have an interface for all files. And so if you want to do static analysis on your text files or on your zip files, or you want to yell at someone for checking a PPL or a DLL in, you can. So it's going to discover all those files and then run rules. A rule is a check that has a result or multiple results, and rules can apply to different classes. So I can have a rule that only applies to VIs, or I can have a rule that applies to every type. Then we've optimized the output of that into three different things. The first one is actually the console output. Because this is a tool designed to run in continuous integration, we want the output to be very accessible. When it fails, I don't want to have to go open up a binary thing or parse some 100,000 lines of XML. I want an email that says, this VI broke. And so we optimize the console output so that would serve that into the CI pipeline. We also create an XML report. We actually use Karaya inside of this to capture all the results and then create a kind of JUnit format XML that can document everything if you need that artifact to turn into NASA, though that is a pretty dense document, so that one's more for them. The one for us is the CSV format. So we're able to take each item times each rule and create a grid of all of the results that is then an easy CSV format that now I can import into Excel and parse and filter and do all kinds of fun things with. All right, so let's jump straight in and let's take a look at the Crawler UI in action. So here we've selected a class. We're going to load all of our items and discover them. We're going to click Run, and you can see it's running all those rules in parallel. In this case, we're then going to check Fix, and not only can it do static analysis, but where appropriate, it can then apply the fix for the failing test. Now, some of those are easier. If separate compiled code is the wrong state, it's pretty easy to set it to the right state. If your VI is broken, we cannot automatically fix that. But I have a bunch of different rules, and you can see I've checked which rules are active for a particular run. I can disable or enable those. I have tags that allow me to see how many of each type of extension or each type of item is in there. And this same multi-column list box format here is exactly what you see in the CSV. So this is the UI, but I'll admit that the UI is not the main way I use this tool, because I almost exclusively use it from the CLI. The times that I do use it from the UI is when I've just created a new class, and I just want to do a quick check. I'll load my class in, and that's exactly what we're seeing here is, just the thing I just worked on. Let me go through, let me automatically fix it. And I can even have rule sets that apply to all of my department. All right, this will just take a second to load. So how many of you work with other developers who broke the code? How many of you have broken the repository? And of course, those always happen Friday afternoon, and you find out you broke it, and maybe you lose some sleep over it, or maybe you have that emergency support. Is this stressing anyone else out? It's a looping GIF. I apologize. So we all hate this, that someone else opened a pull request on our Git branch, they added a new sub VI, they saved it to their desktop because they weren't thinking, they committed to the repo, hashtag works on my machine, but then as soon as I open it, that one's missing. So we want to make this hard. We want to make it hard to do this. So let's talk about the rules that we created for this first NASA project. So the two most useful rules are by far the most useful rule is broken. VA Analyzer has a broken. I think ours is a little better. It gives you a little more info. For instance, it'll identify if it's broken because it's missing dependencies, or if it's broken because it's an orphan, where it says this VI claims to be a member that doesn't claim it. And it also applies to classes, so if your class is missing a member, it'll detect that, even if you have missing project dependencies. We have a rule called libhierarchy that will get mad at you if your child item is not under its parent. Child class members should be next to their class or in a subdirectory next to their class. They should not be in another class. And this often catches when you move a method from one class to another and you move it in the project and forget to move it on disk and bad things happen. We also want to gather basic metrics. One of the NASA requirements is that we had to have a lot of detailed metrics. And in other languages, they would specify these are the standard metrics. And in LabVIEW, we kind of had to make it up. So we said, well, sure. And again, as Greg mentioned, code complexity, size on disk. And again, size on disk can apply to every single file in our repo, not just the VIs. And then VI size, which is, of course, the kind of proprietary VI code size. We're also going to inspect properties. Rules are meant to be opinionated. The metrics rules just give info, just document it. But rules can be opinionated, and so the rule separate compiled code will fail if you do not have your compiled code separated. Same thing with debugging on. We want to make sure that debugging is on by default in our repo. We want to make sure debugging is on in source, and we want to make sure automatic error handling is off. Then we can even enforce some style things. So later I'll show you some of my code and you'll see I'm a big fan of diagram striping, where you alternate white and gray in your structures, and it makes the code really readable. So now I can make sure and check that everything has that striping. I can check for to-dos and just have a nice category of, oh, I forgot to do that to-do before I finished my code. If you wanted to enforce naming conventions, again, on every file in the repo, you could. If you wanted no white space in your names, you could enforce that. Or this one's for Fab, the error Z order. Back last year, I got to present a style debate with Mr. Tom McQuillan, and we had a vigorous discussion of the Z order of errors, and it's important, so you can go check that out. All right. I've talked about some of this in some other presentations, but this is a developer conference, so let's talk about developing rules. This is meant to be a plugin architecture where you can use our standard rules or you can create your own, and it's really straightforward. So rules do use classes. It's a very simple class. There is one required override called ID, and you have to specify a unique ID, a description, and specify whether your rule supports fixes. Some rules do, some rules don't. Then they're actually not class overrides, they're VI templates because we don't want dynamic dispatch overhead. But you can see we have different classes that apply to each of those different things. Who can tell me why I need a special handler class for polymorphic VIs? What's different about polymorphic VIs compared to VIMs, VITs? They don't have block diagrams. And so it's really frustrating when you write a rule and you have to say, oh, okay, if it has a diagram, and so you can do that. But if you wanted to write a rule that's just for VI icons, you could make it apply to both. So we're just going to go through and define which methods ours will apply to, and you can see broken implements one for all the basic LabVIEW classes. This is what a rule looks like. This is what one of those act method look like. We have two inputs, a reference, which in the case of the general item is just a path. In the case of a VI is a VI reference or a class reference or a project reference that has already been opened and loaded into memory for you. You can then do whatever you want. Use VI scripting, use property nodes, use inspection, grab a quick drop and plop it in, grab an existing VI analyzer test and plop it in. Most of those are compatible with this interface. And then the only thing you have to do is create an array of result objects. A result objects includes the data you see there on the screen. The only required one is state. Everything else is kind of done for you. And so for a simple info rule, I just want to look at the file, get the size on disk, I'm going to format it into bytes and then pump that into my summary. Now, summary is meant to be a nice short string, and that's what allows us to do the CSV format. And so if you do need to attach a novel, we do have a details that you can put in that's put in the XML. But optimizing the test for the report view is really important because it makes it a lot easier to understand. If any of you have looked at a VI Analyzer report result, it can be pretty intimidating, especially if you ran a lot of rules. So yeah, these are really simple rules, and rules can have more than one result. If I have a metrics rule and I want to be able to have 2 different metrics, I do have to specify their unique IDs, but then everything else works. This is also a really useful pattern if you want to pre-qualify. So say, for instance, I wanted rules that applied to JKI state machines. First, I want to identify my JKI state machine, then do some set of rules. And so I don't want to have 6 independent rules that are each doing their own independent check for, is this a JKI state machine? I qualify that once and then can run all 6 of my specific rules there. Here's a slightly more complex rule, and again, you can see it's still not very complex. This is one that supports fixing, and so the caller will tell the rule whether it's allowed to make changes, and if that flag is not on, we don't save the VI afterwards, so even if you try to do something, it wouldn't. If we do, then we turn on the flag for record modified changes and then save it at the end. And in this case, this is the rule for detecting if automatic error handling is off, and so basically if we say, if automatic error handling is on and you told me to make changes, we're in a bad state, and we're going to go to that true case, turn it off, and then report the status as fixed. Otherwise, we'll just say if it's pass or failed and have a nice short string that says enabled or disabled. All right, with me so far? Most of you could write a rule in 10 minutes, I'm betting. You already have which rule you would write next? All right, so we need to have some configuration. So we have something called rule sets. A rule set is a set of rules. Rule sets can contain rule sets. And so now I can create my modular interfaces, where now I can say, these VIs need to apply to these rules, and these VIs need to apply to these rules, and these rules are fast and required and have to be run on every pull request, and these rules take a long time and we're going to run them over the weekend. And it allows you to build up flexible. And so I can say for my pull request, I want to make sure it's not broken, I want to make sure my properties are set, but I don't need to measure the size on disk every day. That's not critical for every pull request, but it's nice to know every weekend. And then we also support exemptions where you can say, hey, this one does not apply to this rule. This is a known exception. I decided to put that in the INI file. I generally get a weird feeling about having to change the code to pass the test because the code should kind of stand independently, and so this is a strategy I chose. There's certainly different ways that we could do this moving forward in the future, but this has been very extensible, and that way in one place I have a nice documentation, and I always include why it's exempt in a comment, and maybe even track it with a ticket and say, hey, we need to fix this later, but here's why it's okay for now. It has a CLI argument. Just as Greg mentioned, we do use GCLI. Shout out to Mr. James McNally. I definitely prefer GCLI over the other CLI options because it works great when you're in the development environment, running with everything already opened, and it works great starting from cold. And it works pretty consistently, and the way that it handles arguments is really nice. So these are the arguments we support. Path, we talked about that, what that is. You can specify a timeout. LabVIEW still hangs sometimes, so we do still have to have a timeout. You get your CSV report and your XML report. By default, they'll just be under your root directory, but you can specify a special place. You specify your INI path, and then you have a comma delimited list of rule sets. And so you can say all the required ones plus, since it's Alan, I'm going to add Alan's special test there. And so you can just delimit any number of rules you want, and it'll figure out the common set. And we have batch size. All right, I'm running a little behind, and I may ease over since we had to start late. Okay. We now want to integrate it into Bitbucket. So basically, this is what a Bitbucket YAML looks like. Who here has created a repo YAML before? All right, just a few. And so this is what what Bitbucket is going to look at. Every time I commit, it's going to go through and it can build these GCLI commands. So all I'm doing is building up arguments into a GCLI command, and then you can see at the bottom there, I'm grabbing my 2 reports at the end. This is what it looks like in CI. And so now every time I do a pull request, it's going to run all my unit tests in another step and then run my static analysis. You can see here it made it through 4,220 VIs. I really like that what's in the repo summary in 8 minutes. And then it's going to sort my results, and you can see there the failures at the bottom is really simple. I can see that path failed that rule, and here's the summary of why it failed. That's what I see in my email, and so now when I commit, I can't commit a broken VI to the repo. I can also download that CSV and apply a little bit of Excel formatting, and now have a really useful document with all 4,022 VIs. I can sort by code complexity or find things without automatic error handling or do all kinds of different filters and ways to look through your data. And because these are your rules, you now have the ability to build these up any way you want. All right, last thing I want to quickly talk about is the CWEs. So as part of the NASA requirement, we had to respond to these CWEs, common weakness enumerations. These are basically a list of common computer defects, from writing into an making a pointer math mistake when you're trying to handle memory addresses. And a specific one is OS command injection. Is there a way that someone can inject a string into your application to then do something nefarious that they shouldn't be able to do? And so we wrote a test that said, go find every single sysexec in the whole repo and make sure there's a string constant there. And then I know that I'm not vulnerable to OS injection. And for our first pass, we just said, find them all and I'll manually audit them, because we don't have that many sysexecs in our repo. But now, we did find one that you're like, that one's not good. And so you can refactor it to use a constant instead of taking an argument. So what do we create all this for? So this is our Stargoat application. This is what we're using at NASA. And so in order to now create all of the tooling we needed for this, we also needed a builder. So we have JBuilder that has pretty much the same interface, builds, collects artifacts. We have JTester, which goes on top of Karaya. It does add code coverage metrics, which base Karaya doesn't have. But if you're not using Karaya, it's free, it's great. And now we have a fully automated pipeline. Every time we commit, our self-hosted Windows runner is going to kick off, run through all of our crawler jobs, collect all of our results. And now every single time I do a build, I have this document that I can turn into NASA. If it fails, it emails me, and it's really easy to read. All right. So from here, we want to continue to build out rules. We want to port VI analyzer tests. I happen to have access to the titular Mr. Jim Kring, and so that gives us powers to do some great things with Dragon. I know Jim's going to talk a little bit more about some of his projects in his 7x7, so I won't spoil it, but when you're watching that, think there's some ways we can integrate crawler. So a lot of times we work with customers, we'll go through and do a full evaluation. Sometimes they need help getting on Git. Sometimes they have that part, but they need build, or they need test, or they need inspect. So we'll teach them how to write test, and we'll stand up all these things so that we can identify the time sinks, pitfalls, dreams, and artifacts. And so this is a common way that we sit down with customers and make these tools available. So we are partnering with a few small aerospace opportunities right now to kind of build this out. We're really focusing on this kind of high assurance requirement situations. But we do want to make this tool more available, and so if you have great ideas of how you would use this to improve your code quality, please let me know. And I think I'm just at time, so I won't have time for questions, but please find me or any of our nice green shirts, and we'll be happy to chat. Thank you.